So here's the problem with this one. You have to try to figure out what form it is. Is this b to the x? Is this x to the n? Because those are our two choices. And you will notice, do I have a constant to a variable or a variable to a constant? And the answer is no, I have neither. There is a variable and there is a variable. One of these, there's a constant in one position and that doesn't fit. So because of that, we are in trouble because we can't do this as it is. But we are gonna take the power of logs and do incredible things. So I'm gonna log both sides because if these two are equal, then the logs of each side need to be equal. Then you know the p in front of the log rule. If I have a log of an exponent, I can take the exponent and p, put that power, whoa, that's kind of cool, huh? I can take that power and put it in front. So now I can rewrite it as ln of y equals cos x ln of x. Now I have just a product rule. I can do that. Product. And be careful because y is our function. So when we take the derivative of the left side, that's implicit differentiation. So be careful with that. So what's the derivative of ln of box? It's going to be 1 over box times the derivative of box. And remember, that's what we're trying to find, so that's a good thing. Product rule, leave the first alone, take the derivative of the second, plus take the derivative of the first and leave the second alone. And we're almost finito. So let me rewrite this and tell you the last step. It's going to be cos x over x, I just combined those two, minus sine x ln x. But my goal was to isolate dy dx, so I need to get rid of 1 over y, so I'm going to multiply both sides by y. Why? Because that's what I need to do. Don't forget to parenthesize that. You're multiplying the whole thing by y. Those will cancel. And then I have this, dy dx equals cos x over x minus sine x ln of x times y. But what is y? We need to go back to the original and say, that's y. Y is x to the power of cos x. So in place here, I put x to the power of cos x. All right, we're almost done. Remember what we're trying to find. We want also the derivative at pi over 2. That's what they're asking for. So I'm going to plug pi over 2 for all my x's. So that's going to be cos pi over 2 over pi over 2 minus sine pi over 2 ln of pi over 2 and pi over 2 raised to the cos pi over 2. All right, unit circle. I've seen some of you have started watching my unit circle video. Good job. Keep up the good work. It's going to help you. Hopefully it's helped you. But let's do these real quickly. Cosine of pi over 2, that's 0. So that's gone because the x coordinate at pi over 2 is 0. Let's keep going. Sine of pi over 2, that's going to be 1. ln of pi over 2, I'm not a calculator, so I don't know how to do that. I leave it as that. Cos of pi over 2, we just said that's 0. So what do we have here? We have 1 ln of pi over 2 times pi over 2 to the 0 power. But what's anything to the 0 power? Hold up your hands. Anybody? I see a 1. Good job, good job. It's 1. So this is replaced by 1. So our answer is ln of pi over 2. So we also have the negative there, so our answer is actually negative ln of pi over 2.